Imagine standing at the edge of a cosmic abyss where space itself twists into oblivion and entire stars vanish without a trace. These aren't scenes from science fiction. They're real places scattered across the universe where the laws of physics seem to break and danger lurks in every shadow. From the crushing depths of black holes to the searing fury of radiation storms, the cosmos is filled with unimaginable horrors that defy everything we know about survival. Welcome to the top 25 most dangerous places in the universe, a journey through the deadliest corners of existence where even light isn't safe. Picture a realm where gravity is so strong it bends time itself, where rogue planets drift through the void, stripped of their stars, their surfaces frozen in perpetual darkness. Think of neutron stars spinning so fast they could rip atoms apart with their sheer force, or quasars blazing with the energy of 1,000 galaxies. These aren't just hostile environments, they're nightmares on a cosmic scale, places where the universe shows its most violent, unforgiving face. And yet, they hold secrets that could rewrite our understanding of reality itself. This isn't just a list of terrifying destinations. It's an expedition into the unknown, a chance to confront the extremes that shape our universe. Some of these places are so destructive, they challenge the very notion of what's possible. Others hide mysteries that scientists are only beginning to unravel. But one thing's certain: by the time we're done, you'll never look at the night sky the same way again. So brace yourself. We're about to venture into the most lethal corners of existence where danger isn't just a possibility, it's the only rule. At the heart of our own galaxy, hidden behind swirling clouds of cosmic dust, lies a monster with an appetite so vast it could swallow our sun without a second thought. Sagittarius, a star, the supermassive black hole anchoring the Milky Way, is a gravitational titan weighing in at a staggering 4 million times the mass of our sun. This isn't just a void in space, it's a relentless predator warping the fabric of reality around it. Picture a star drifting too close to its grasp. The black hole's tidal forces stretch and compress it like taffy in a process scientists call spaghettification. Gas and plasma are torn apart in violent streams, spiraling toward the event horizon, the point of no return where even light surrenders. What's left behind? An eerie silence. No explosions, no dramatic bursts, just the cold, indifferent pull of oblivion. But Sagittarius, a star, isn't just a destroyer. It's also a cosmic mystery. Thanks to the Event Horizon telescope, we've glimpsed its shadow, a haunting silhouette against the glow of superheated matter. These images reveal a swirling maelstrom of magnetic fields and debris, a chaotic dance that defies imagination. And yet, for all its fury, the black hole is strangely quiet, biding its time between meals. What happens if you crossed the event horizon? Time itself would twist around you. From the outside, you'd appear frozen, as if pressed into the fabric of space forever. But for you, the fall would be terrifyingly quick into a place where the laws of physics as we know them simply break down. This is the realm of the unknown, where gravity reigns supreme and the universe writes its own rules. Drifting through the endless dark between stars, PSO J318.5-22 isn't just a planet without a sun. It's a frozen exile, banished from the warmth of any solar system. Imagine a world where the temperature never climbs above negative 263 degrees Celsius, where the very air could freeze solid in an instant. This rogue planet isn't just cold, it's a graveyard of heat, a place where the concept of daytime doesn't even exist. What makes this world so treacherous isn't just the absence of light. Its atmosphere, if you can even call it that, is a suffocating blanket of pressure, crushing down with forces that would flatten a submarine like aluminum foil. Unlike Earth's gentle blue skies, this planet's gaseous layers churn in a perpetual storm with winds that could shred metal. And because there's no star to warm its surface, the entire world is locked in a deep freeze with glaciers of exotic ices that might never melt. But here's the real horror. PSO J318.5-22 isn't orbiting anything. It's wandering through interstellar space utterly alone, a cosmic castaway with no destination. Some scientists think it might have been flung away from its parent star by a violent collision, while others suspect it formed in isolation, a failed star that never ignited. Either way, it's a monument to desolation, proof that the universe doesn't need black holes or supernova to create places of absolute dread. And yet, for all its hostility, rogue planets like this might be far more common than we think. Astronomers estimate billions could be drifting unseen in the darkness between stars, invisible to our telescopes. Some might even have thick, heat-trapping atmospheres, hiding subsurface oceans where bizarre life could cling to existence. But on PSO J318.5-22, the only certainty is a cold, silent death, a reminder that in the cosmos, isolation itself can be the deadliest force of all. If you think Earth's hottest deserts are brutal, Kelt 9b will make them feel like a winter retreat. This exoplanet is a blistering hellscape where temperatures soar to 4,300 degrees Celsius on its dayside, hotter than the surface of some stars. Imagine a world so scorching it doesn't just melt rock, it vaporizes entire atmospheres, leaving behind a ghostly trail of ionized metals like titanium and iron. This isn't just a planet, it's a cosmic furnace rewriting the rules of what we thought planetary survival could look like. Kelt 9b's torment comes from its cruel dance with its parent star. Tidally locked, one side of the planet is forever bathed in searing starlight, while the other languishes in perpetual darkness. But even the night side offers no refuge, as scorching winds carry heat across the terminator, superheating the entire world. The star it orbits isn't just hot. It's a blue giant blasting out ultraviolet radiation with such intensity that the planet's atmosphere boils away at a rate of 10,000 tons per second. The result, a colossal, glowing tail of vaporized material stretching into space like a comet on a doomed journey. What's truly unsettling is how this world defies expectations. Most gas giants cling tightly to their atmospheres, but Kelt 9b is literally cooking itself into oblivion. The extreme heat rips molecules apart, breaking them down into solitary atoms that glow under the star's relentless assault. And because the planet orbits so close, completing a year in less than 2 Earth days, it's caught in a death spiral, slowly being consumed by its own star. Scientists call this phenomenon atmospheric escape, but that term doesn't capture the violence of what's happening here. This is planetary erosion on a staggering scale, a preview of what could happen to other worlds too close to their stars. Yet somehow, against all odds, Kelt 9b persists a burning enigma, teaching us just how extreme the universe can get when it decides to test the limits of existence. When a star dies, sometimes it leaves behind more than just a corpse, it spawns a nightmare. Meet SGR 1806-20, a magnetar so terrifying it makes black holes seem almost polite. This neutron star doesn't just have a magnetic field, it wields a force 1 quadrillion times stronger than Earth's, a pull so intense it could strip the electrons from your atoms from 1,000 kilometers away. You wouldn't just die, you'd disintegrate on a molecular level, unraveling like a thread in cosmic wind. What makes this monster even more unsettling is its temper. In December 2004, SGR 1806-20 threw a tantrum so violent it sent a gamma-ray blast across 50,000 light-years, and yet it still managed to punch Earth in the ionosphere. For a brief moment, our planet's upper atmosphere was ionized, disrupting radio communications worldwide. If this outburst had happened within 10 light-years of us, it could have triggered a mass extinction, scrubbing the ozone layer into oblivion. The physics behind magnetars bends reality itself. Imagine a stellar core so dense, a teaspoon of it would weigh billions of tons, spinning faster than a kitchen blender. That rotation, combined with swirling currents of superheated plasma, generates magnetic fields strong enough to twist space-time. These fields crack the star's crust like eggshells, releasing bursts of energy so bright they outshine entire galaxies for milliseconds. But here's the twist: magnetars are fleeting monsters. Their magnetic fields decay over time, and within 10,000 years, a blink in cosmic terms, they fade into quiet neutron stars. That means SGR 1806-20 is a ticking time bomb, its power draining away with each passing century. Yet while it lasts, it serves as a chilling reminder: the universe doesn't need black holes to be deadly. Sometimes all it takes is a magnetized corpse spinning in the dark. Deep in the heart of the Large Magellanic Cloud, a cosmic tempest rages, one so fierce it could sterilize entire solar systems before they even form. The Tarantula Nebula might sound like a place of delicate beauty, but don't let the name fool you. This so-called stellar nursery is less a cradle and more a war zone, where newborn stars unleash torrents of ultraviolet radiation strong enough to rip apart molecules and blast away the raw materials for planets. At the center of this chaos sits R13601, a hypergiant so colossal it defies belief. With a mass 260 times that of our Sun and blazing at nearly 9 million times its brightness, this star is less a celestial object and more a natural disaster. Its solar winds don't just gently push against nearby space, they scream outward at nearly 3,000 kilometers per second, carrying enough energy to strip atmospheres from planets light years away. Imagine standing on a hypothetical world in this nebula. The sky wouldn't just glow, it would sizzle as relentless UV radiation ionizes the air itself, turning it into a lethal plasma storm. What makes the Tarantula Nebula especially treacherous is its deceptive productivity. While it's true that stars are born here at a frenetic pace, most of them never get the chance to form stable planetary systems. The radiation is so intense, it evaporates protoplanetary disks, the swirling rings of dust and gas that would otherwise coalesce into planets before they can even take shape. It's like trying to build a sandcastle in a hurricane. Yet somehow, against all odds, a few hardy star systems persist on the nebula's fringes, clinging to existence in the brief calm between radiation blasts. These survivors offer a glimmer of possibility, proof that even in the universe's most hostile environments, life might still find a way, but for the majority of the tarantula's stellar offspring, their fate is to be born into a storm where the very light that gives them life also ensures their planetary systems never will. Some stars don't just wander, they flee. Hurtling through the Milky Way at speeds exceeding 3 million kilometers per hour, hypervelocity stars are cosmic fugitives, flung into the void by forces beyond comprehension. These aren't gentle drifters, they're projectiles ejected by the gravitational slingshot of supermassive black holes, carrying enough energy to cross entire galaxies in mere cosmic eye blinks. And wherever they go, they leave behind a trail of devastation. Take S5 HVS1, one of the fastest known hypervelocity stars. Racing outward at nearly 2.7 million kilometers per hour, it moves so fast it's not even bound by the Milky Way's gravity. But speed alone isn't what makes these stars deadly. As they plow through interstellar gas, they generate shockwaves so powerful they ionize everything in their path, stripping electrons from atoms and leaving behind a wake of superheated plasma. These shockwaves act like cosmic snowplows, piling up gas and dust into crushing walls of pressure walls that can trigger chaotic star formation or obliterate fragile protoplanetary disks in their way. Then there's the invisible carnage. Hypervelocity stars don't just move fast, they're natural particle accelerators, scattering lethal cosmic rays like celestial shrapnel. These high-energy particles, ejected at near light speed, could irradiate entire star systems, stripping atmospheres or mutating DNA on any unlucky world in their crosshairs. Imagine a star passing even a light year away, close enough for its cosmic rays to bombard a planet with radiation equivalent to 1,000 nuclear bombs detonating every second. Life as we know it wouldn't stand a chance, but the most chilling part, hypervelocity stars aren't rare. Astronomers estimate thousands could be streaking through our galaxy right now, unseen until it's too late. Some might even be rogue exoplanets torn from their orbits and sent careening into the dark. And while Earth is safe for now, the Milky Way is a shooting gallery, proof that sometimes the greatest danger isn't standing still. It's moving faster than anything should. Venus was once called Earth's twin, a lie wrapped in swirling clouds of sulfuric acid. Beneath that deceptively soft glow lies a world of relentless fury, where the air itself is a toxic, superheated sludge and the ground burns hot enough to melt lead. At 462 degrees Celsius, its surface temperature could bake a pizza in seconds, while atmospheric pressure crushes down with the force of an ocean trench 92 times heavier than Earth. This isn't a planet, it's a pressure cooker from hell disguised as a jewel in the twilight sky. The Soviet Union's Venera probes learned this the hard way. Designed to survive the impossible, these brave little machines plunged into Venus's thick haze in the 1970s and 80s, radioing back data as they fought against the planet's wrath. Venera 13, the most successful, lasted just 127 minutes before the heat fried its circuits and the pressure crumpled its titanium hull like a soda can. Its final images show a desolate wasteland of cracked bedrock under an orange-brown sky, where rain falls as sulfuric acid droplets only to evaporate before hitting the ground, condemned to an endless cycle of torment. What makes Venus truly sinister isn't just the heat or the acid. It's the runaway greenhouse effect that turned a potentially habitable world into a cosmic inferno. Sunlight filters through those beautiful clouds, but the thick carbon dioxide atmosphere traps the heat like a blanket, creating temperatures that would make Mercury blush. The mountains, they're capped with metallic snow, not water, but volatile compounds like lead sulfide and bismuth sulfide, vaporized at lower elevations and frozen at the peaks. Even the wind here is vicious, howling at hurricane speeds high in the atmosphere, though barely a breeze stirs at the surface, stifled by the crushing weight of the air. Yet Venus wasn't always this way. Some scientists believe it may have had oceans, even a temperate climate, billions of years ago. A slight nudge in solar radiation, a volcanic belch of too much carbon dioxide, and the balance tipped. Now it stands as a warning, a glimpse of what Earth could become if our own climate spirals out of control. The acid clouds aren't just a curiosity. They're a funeral shroud, proof that even paradise can curdle into a nightmare when the universe decides to flip the rules. Beneath the eerie pulsations of a dead star, a world unlike any other spins in silent, glittering agony. PSO J318.5-2438b isn't just a planet, it's a cosmic jewel, its entire mass crushed into a sphere of crystalline carbon so dense, a sugar cube-sized chunk would weigh more than an elephant. This is no ordinary diamond, it's the fossilized heart of a once mighty star, a celestial tombstone forged in the crucible of gravitational collapse. And its surface isn't just hard, it's a death sentence where gravity's grip is 30,000 times stronger than Earth's, enough to reduce a human body to a smear just one atom thick. The nightmare begins with the planet's birth. Billions of years ago, its parent star, a white dwarf, was locked in a lethal dance with a pulsar, a spinning neutron star blasting beams of radiation like a cosmic lighthouse. As the pulsar siphoned away the white dwarf's outer layers, what remained was a carcass of pure carbon, squeezed under pressures so extreme, its atoms snapped into the rigid lattice of diamond. The result, a planet smaller than Jupiter but with half its mass, compressed into a space barely wider than Earth. If you could stand on its surface, which you can't, because you'd instantly become a puddle of subatomic particles, the sky would be dominated by the pulsar's hellish glow, a strobe light of radiation pulsing with metronome precision, each burst carrying enough energy to sterilize a continent. But the real horror lies deeper. Unlike Earth's molten core, this planet's interior isn't liquid metal, it's degenerate matter, a quantum mechanical nightmare where electrons are squeezed so tightly they form a soup of indistinct particles. The crust, likely a labyrinth of diamond mountains, their peaks sharp enough to puncture spacecraft hulls, frozen in place by gravity's unrelenting grip. And because the planet orbits its pulsar so closely, completing a year in just 2 hours, tidal forces stretch and compress it like putty, generating internal heat that keeps the diamond slightly pliant, a slow-motion glacier of gemstone. What's truly unsettling is how this world defies expectation. Planets like this shouldn't exist. The pulsar's radiation should have vaporized it, or the original white dwarf should have detonated as a supernova. Yet here it spins, a glittering anomaly, proof that the universe enjoys turning celestial junk into impossible wonders. For scientists, it's a treasure trove, literally. For the rest of us, a chilling reminder that even the most beautiful things in space can kill you in ways we're only beginning to understand. Two galaxies locked in a death spiral. This is the fate of NGC 4038 and NGC 4039, better known as the antennae galaxies. Their elegant, intertwined tails of stars and gas might look like a cosmic ballet from afar, but up close, this is a battlefield where entire solar systems are born and obliterated in the same breath. Here, gravity isn't just a force, it's a wrecking ball, hurling stars into chaotic orbits, smashing gas clouds into superheated shockwaves, and birthing supernovae so frequent they light up the night sky like fireworks on a loop. This collision didn't start yesterday. It began hundreds of millions of years ago when these two galaxies first brushed against each other, their mutual pull distorting their shapes into those iconic tidal tails. Now they're in the final act, their cores merging into a single, seething mass of newborn stars and ancient wreckage. The star formation rate here is staggering. Dozens of new stars ignite every year, each one a potential death sentence for nearby planets. Radiation from these stellar newborns carves through surrounding nebulae, while supernovae blast away the raw materials for future worlds before they can even form. But the real danger lies in the unseen. As the galaxies merge, their central black holes, once orderly rulers of their own domains, are now destabilized, flung into erratic orbits like derailed locomotives. Some may have already been ejected entirely, drifting through intergalactic space as rogue predators. Others are spiraling toward an inevitable collision, their paths littered with the corpses of stars torn apart by their gravity. When they finally merge, the resulting gravitational waves will ripple across the universe, a farewell note to one of the most violent events imaginable. Yet amid the chaos, there's eerie beauty. The antennae's brightest regions glow with the light of young star clusters, their blue-hot brilliance cutting through the dust. Some of these stars may even host planets, worlds born into a storm, orbiting suns that could explode or be flung into the void at any moment. For now, the galaxies continue their dance, a slow-motion train wreck that won't finish for another few 100 million years. But for any hypothetical life caught in the crossfire, the universe offers no shelter, only a front-row seat to its most spectacular demolition derby. Hidden in the constellation Virgo, a cosmic blowtorch slices through the void with the fury of a million suns. Quasar 3C273 might look like a harmless speck of light in telescopes, but its true nature is anything but peaceful. At its core, a supermassive black hole nearly 900 million times the mass of our Sun feasts on an endless buffet of gas and dust. And when this monster eats, it doesn't just swallow matter quietly. It spits part of it back out as a relativistic jet, a 40 light-year-long spear of plasma traveling at 99.9% the speed of light, so bright it outshines entire galaxies. This isn't just a beam of light, it's a particle accelerator on a cosmic scale where magnetic fields twist into coils tighter than DNA, launching electrons to energies beyond anything humanity's most powerful colliders could ever achieve. The jet's tip glows with X-rays and gamma rays, while its sides ripple with radio waves, a lethal cocktail of radiation spanning the entire electromagnetic spectrum. If Earth found itself within a light year of this jet, the effects would be apocalyptic. The initial blast would deliver enough gamma radiation to boil away our atmosphere within hours. Surface temperatures would skyrocket to thousands of degrees, transforming oceans into steam and continents into molten slag. Even the planet's crust wouldn't survive. The jet's kinetic energy alone would bombard it with particles moving fast enough to shatter atomic bonds, effectively sandblasting rock into vapor. Yet 3C-273's most terrifying feature isn't its destructive power, it's its precision. Unlike a supernova's expanding shockwave, this jet is a focused beam, narrowing to just a few degrees across. That means while most of its energy stays concentrated, anything unlucky enough to fall directly in its path receives the full force of a cosmic flamethrower. Astronomers have watched blobs of plasma within the jet move at apparent speeds faster than light, an illusion caused by their near-light-speed trajectory straight toward us. In reality, these plasma bullets could cross the distance from Earth to Pluto in less than a day. What's truly unsettling is how common quasars like this might have been in the early universe. Billions of years ago, when galaxies were younger and their central black holes had more fuel to consume, jets like these likely crisscrossed the cosmos, sterilizing entire swaths of space. Today, 3C-273 serves as a relic of that violent era, a reminder that the universe doesn't just create life-friendly environments. Sometimes it builds engines of pure annihilation, turning the very fabric of space into a weapon. Even in the frozen reaches of the solar system, where temperatures plunge to near absolute zero, the universe finds ways to unleash violence. On Pluto's distant surface, a towering behemoth named Right Mons looms over the icy plains. Not a mountain of rock, but a colossal cryovolcano, its slopes stained with the remnants of eruptions that defy earthly logic. Here, volcanoes don't spew molten lava. They vomit rivers of ammonia-laced slush, a toxic slurry chilled to -200 degrees Celsius, flash freezing anything foolish enough to stand in its path. When NASA New Horizons probe revealed Right Mons in 2015, scientists were stunned. This wasn't just a relic of past eruptions, it was evidence of a geologically active Pluto, a world far from the static ice ball we once imagined. Towering 4 kilometers high and stretching 150 kilometers across, the volcano's summit hides a gaping depression, a scar left by ancient outbursts. But what fuels these eruptions in a place so cold, so distant from the sun's warmth? The answer lies beneath Pluto's frozen crust, a hidden ocean of water and ammonia, kept liquid by the decay of radioactive elements and the lingering heat of the dwarf planet's formation. When pressure builds, this sludge punches through the surface, exploding into the vacuum with a force that would make Mount Vesuvius look like a campfire. The aftermath is even more surreal. As the ammonia-rich mix hits the surface, it doesn't just flow, it freezes in an instant, forming bizarre, wrinkled terrains that resemble elephant skin. These frozen floods are laced with organic compounds, staining Pluto's surface with patches of reddish-brown like cosmic rust. And because the dwarf planet's gravity is so weak, just 6% of Earth's, the slush can climb absurdly high before collapsing, creating chaotic landscapes of icy cliffs and frozen waterfalls. Yet Right Mons isn't just a geological oddity, it's a warning. Cryovolcanoes like this might exist all over the Kuiper belt, lurking on distant worlds like Eris and Makemake. And if they're erupting, they could be reshaping these alien landscapes in real time, proving that even in the darkest, coldest corners of the solar system, the ground beneath your feet is anything but still. For explorers, that means one thing. In the outer reaches of space, the real danger isn't just the cold, it's the ice that moves. Eta Carinae isn't just a star, it's a cosmic powder keg, a binary system so volatile it could rewrite the night sky in an instant. This celestial time bomb consists of two massive stars locked in a lethal dance, one a blue hypergiant nearly 100 times heavier than our Sun, the other a smaller but equally unstable sibling. Together, they're a disaster waiting to happen, and history proves they don't need an invitation to erupt. In 1843, Eta Carinae gave humanity a preview of its destructive power. Without warning, it exploded in what astronomers call the Great Eruption, a cataclysmic outburst that hurled enough material into space to form 10 suns. For a brief moment, this single star outshone every other light in the Milky Way, visible even in broad daylight from Earth. The explosion didn't just brighten the sky, it sculpted the homunculus nebula, a vast hourglass of glowing gas expanding outward at millions of kilometers per hour. Today, those twisted tendrils of dust and ionized matter still bear the scars of that violent tantrum, stretching across trillions of kilometers of space. But here's the terrifying part. Eta Carinae isn't done. Scientists believe the Great Eruption was just a warm-up for the main event, a supernova so powerful it could outshine the moon in our sky. When that happens, and it's a matter of when, not if, the blast will unleash a gamma-ray burst capable of sterilizing every habitable planet within 50 light-years. Gamma rays, the most energetic form of light, would rip through atmospheres like bullets through tissue paper, stripping away ozone layers and exposing surface life to lethal ultraviolet radiation. The explosion might even birth a magnetar, leaving behind a spinning, magnetic corpse more dangerous than the original star. What makes Eta Carinae especially unpredictable is its sheer instability. Most stars die with some warning, shedding mass gradually as they age. But Eta Carinae is a roiling pressure cooker, its outer layers barely held together by gravity. Turbulent convection currents churn beneath its surface, while radiation pressure fights a constant war against collapse. Even the smallest star in the binary system adds fuel to the fire, its gravity tugging at the hypergiant's outer layers, triggering violent mass ejections. For now, we're safe. Eta Carinae sits 7,500 light-years away, far enough that its eventual supernova won't threaten Earth, but for any civilization unlucky enough to lie within its kill zone. There'd be no time to react, no chance to flee. One moment, a familiar night sky, the next, a blinding flash rewriting the rules of existence. And that's the chilling lesson of Eta Carinae. In the cosmos, even the brightest lights can be harbingers of annihilation. In the vast cosmic tapestry littered with luminous stars and swirling galaxies, Dragonfly 44 stands as an enigma wrapped in shadow. This ultra-diffuse galaxy glows so faintly it was overlooked for decades, a ghostly smudge against the blackness of space. But when astronomers finally measured its mass, they stumbled upon a chilling truth. 99.99% of Dragonfly 44 isn't just invisible, it's something we can't even see. This galaxy isn't made of stars, gas, or dust. It's a halo of pure dark matter, a gravitational phantom holding together a handful of visible stars like fragile ornaments in an invisible web. The numbers defy logic. Despite spanning as wide as the Milky Way, Dragonfly 44 contains only 1/1000th of our galaxy's stars, yet somehow it weighs just as much. The unseen mass lurking in its outskirts exerts a gravitational pull so immense, it warps the fabric of space itself. Stars orbiting the galaxy don't move in stately ellipses, they're yanked into chaotic paths, whipped around by tidal forces strong enough to tear them apart atom by atom. Picture a world caught in this maelstrom. its skies wouldn't show a serene Milky Way-like band, but a fractured, shimmering haze of stars stretched into grotesque shapes, pulled like taffy by an unseen hand. What makes Dragonfly 44 truly unsettling is what it implies about the universe. Dark matter was always thought to be the scaffolding around which galaxies form, an invisible glue. But here, the scaffolding has almost no building. It's as if the universe forgot to add the stars, leaving behind a gravitational trap made of nothing. Some theories suggest this galaxy might be a failed Milky Way, a place where normal matter was stripped away by ancient collisions, leaving only its dark matter skeleton. Others propose it's a cosmic fossil, a relic from an era when dark matter clumped differently, creating these eerie, star-starved husks. But the most terrifying possibility: Dragonfly 44 isn't alone. Surveys suggest thousands of similar dark matter halos could be drifting unseen, their gravitational tendrils silently warping space around them. If one passed through our solar system, we might not notice, until the tides began to rise uncontrollably, until Earth's orbit subtly shifted, until the moon's pull suddenly wasn't the only force tugging at our oceans. The universe is full of monsters, but none as haunting as those we can't even see. If hell had a postcode, it might be stamped across the tortured surface of Io. Jupiter's innermost large moon isn't just volcanically active, it's a full-blown inferno, a world where the ground itself is a writhing, molten nightmare. Rivers of lava wider than the Amazon carve channels through valleys of sulfurous rock. While volcanic plumes erupt with such violence, they spew molten rock 500 kilometers into space high enough to reach the edge of Earth's atmosphere if they happened here. This isn't just geology gone wild. It's a relentless display of celestial brutality, where temperatures soar past 400 degrees Celsius, and the very air, what little there is, stinks of rotten eggs from endless streams of sulfur dioxide. What fuels this chaos isn't some internal furnace, but Jupiter's ruthless gravitational grip. Locked in a cosmic tug of war with its sibling moons Europa and Ganymede, Io is stretched and squeezed like putty, its crust buckling under tidal forces strong enough to lift entire landscapes by 30 meters, the height of a 10-story building before slamming them back down. The result, a world perpetually quaking, its surface riddled with fractures that ooze lava like bleeding wounds. The largest of these molten scars, Loki Patera, is a lava lake 200 kilometers across, bigger than Lake Ontario, with a crust so thin it regularly collapses, triggering eruptions visible from space telescopes. But Io's true horror lies in its silence. Without an atmosphere to carry sound, these apocalyptic eruptions happen in eerie quiet. You wouldn't hear the roar of collapsing lava crust or the hiss of escaping gases, just the vibrations of the ground beneath your feet, if you could stand there without vaporizing. The volcanic plumes, rich in sodium and sulfur, paint Jupiter's magnetosphere with a glowing donut of ionized poison, a radioactive belt so intense it would fry unshielded electronics in seconds. Yet for all its fury, Io holds a strange beauty. The moon's palette yellows from sulfur, reds from molten silicate rock, and blacks from freshly cooled lava makes it look like a cosmic Jackson Pollock painting. Some lava flows are so hot they glow in the dark, visible against the moon's shadowed surface like neon veins. And because Io orbits Jupiter every 42 hours, its volcanic activity follows a frantic rhythm, with eruptions peaking as the moon whips around its closest approach to the planet. What's most unsettling, though, is Io's inevitability. Unlike Earth's volcanoes, which rest between eruptions, this moon has no off switch. Its torment will continue until Jupiter's gravity eventually rips it apart or flings it into space. Until then, it remains a stark reminder, even in the stillness of space, there's no peace, only violence frozen in time. Most voids in space are just empty stretches between galaxies, but Boötes Roman 3 isn't most voids. Spanning a staggering 330 million light-years, this cosmic desert isn't merely empty. It's an abyss so vast and barren, entire galaxy clusters could vanish into its depths without brushing against a single star. Here, temperatures hover just fractions of a degree above absolute zero, the coldest possible state of matter. This isn't just space, it's space stripped to its bones, a vacuum so pure it defies comprehension. Imagine drifting through Boötes Roman 3. The darkness isn't just an absence of light, it's an active erasure. With no galaxies to reflect or emit radiation, your eyes would register nothing, no matter how long they adjusted. The cosmic microwave background, the faint afterglow of the Big Bang, would be your only companion, a whisper of heat from a universe that forgot this place existed. And if you somehow survived, the void's expansion would carry you away from everything you'd ever known, faster than light could chase you. You wouldn't just be lost, you'd be irretrievable. What makes Boötes Roman 3 truly haunting is the fate of the rare, island universes trapped inside it. These lone galaxies, like MCG plus 1-2-1, are marooned in a sea of nothingness, their light taking billions of years to reach any neighbor. Without galactic collisions or mergers to spark new stars, these isolated worlds age in solitude, their gas reservoirs slowly depleting until they fade into darkness. The Milky Way, with its bustling satellite galaxies and nearby Andromeda, is a metropolis compared to these cosmic hermits. Scientists call these voids, the universe's fossil structures, relics from an era when matter clumped unevenly after the Big Bang. While most regions collapsed into dense webs of galaxies, places like Boötes Roman 3 were left behind, stretched thinner by cosmic expansion until they became true nothingness. Some theories suggest dark energy, the mysterious force accelerating the universe's expansion, might thrive here, its influence unchecked by gravity. If that's true, Boötes Roman 3 isn't just empty. It's a preview of the entire universe's fate, a future where all galaxies are ripped apart, leaving only an endless, lightless void. Yet even here, there's eerie beauty. The few photons that traverse this wasteland arrive untouched, pristine records of ancient cosmic events. For astronomers, Boötes Roman 3 is both a warning and a laboratory, proof that the universe doesn't just create. It also erases, leaving behind voids so absolute they redefine the meaning of emptiness. Most black holes lurk in the shadows, anchored to their galaxies by gravity's unbreakable chains, but not HVS-1. This four solar, mass renegade rockets through intergalactic space at 1,600 kilometers per second, fast enough to cross the distance from Earth to the Moon in under 4 minutes. Unlike its stationary cousins, this cosmic fugitive doesn't orbit anything. It's a runaway bullet fired from the Milky Way's core, leaving behind a trail of devastation that rewrites everything we thought we knew about black hole behavior. The violence of HVS-1's birth rivals its current rampage. Astronomers believe it was catapulted into the void when its parent black hole, Sagittarius A star, violently ejected it during a 3-body gravitational interaction. Picture the scene, 3 black holes orbiting each other in a lethal dance, their paths tightening until 2 merge in a burst of gravitational waves, while the third is slingshotted outward like a stone from a catapult. The recoil was so powerful, HVS-1 achieved escape velocity from our galaxy, destined to drift forever through the emptiness between galactic clusters. But speed alone isn't what makes this rogue so deadly. As it plows through interstellar gas, its gravitational pull shreds atoms into superheated plasma, creating an accretion disk that glows with X-rays millions of times more intense than our sun's full output. Any solar system unfortunate enough to lie in its path would face sterilization on a planetary scale. The initial X-ray blast would ionize atmospheres, strip away ozone layers, and bombard surfaces with radiation equivalent to detonating a nuclear bomb every square kilometer. Complex molecules, the building blocks of life, would be reduced to their elemental components in seconds. What's truly chilling is how stealthy this predator remains. Unlike quasars or active galactic nuclei, HVS-1's lethal emissions are narrowly focused, meaning you might not detect its approach until the radiation front was already upon you. A habitable world could orbit a star just outside the direct path and still suffer atmospheric collapse from secondary particle showers, their biospheres collapsing long before the black hole itself passed by. Yet HVS-1 isn't entirely a force of destruction. Its breakneck journey offers scientists an unprecedented lab for studying black hole dynamics. The way it interacts with interstellar gas reveals secrets about dark matter distribution, while its trajectory provides clues about the Milky Way's violent past. And if humanity ever masters interstellar travel, rogue black holes might serve as gravitational slingshots, natural accelerators for crossing unimaginable distances. For now, though, we can only watch as this cosmic outlaw streaks toward the void, a reminder that even the darkest objects in space sometimes yearn to break free. Where it's headed, no one knows, but one thing's certain: whatever lies in its path won't survive the encounter. Beneath Neptune's serene blue veil lies a storm of unimaginable extravagance, a world where the sky doesn't rain water but diamonds. This isn't poetic exaggeration. It's a violent meteorological reality forged in the planet's crushing depths. Here, methane, the same gas that fuels stoves on Earth, shatters under pressures 6 million times stronger than our atmosphere, its carbon atoms squeezed into crystalline structures that plummet through liquid carbon oceans like glittering artillery. The process begins in Neptune's upper atmosphere, where methane molecules drift among hydrogen and helium. As you descend, temperatures soar to thousands of degrees and pressures mount to levels that distort chemistry itself. The methane's hydrogen atoms are torn away, leaving raw carbon to be compressed into diamond. These aren't the delicate gemstones mined on Earth, they're monstrous chunks, some as large as icebergs, hurtling downward at supersonic speeds. Scientists call it diamond rain, but that gentle phrase betrays the violence. Imagine a hailstorm where every pellet could pierce steel, superheated by friction as it screams through Neptune's sludgy interior. What's even stranger is where these diamonds end up. Neptune's mantle isn't solid rock but a vast ocean of supercritical fluid, a state of matter that's neither liquid nor gas, where carbon swirls in a chaotic, electrically conductive soup. The falling diamonds don't just vanish, they're likely slowed by this viscous sea, piling up near the core in layers so thick they might form a diamond crust hundreds of miles deep. Some theories suggest the friction between these sinking diamonds and the surrounding fluid could generate electric currents, contributing to Neptune's mysteriously powerful magnetic field, one that tilts wildly and doesn't align with the planet's rotation. The irony is delicious. On Earth, diamonds are symbols of luxury, painstakingly extracted from mines. On Neptune, they're as common as dirt, forged in endless cascades beneath raging winds that howl at 2,000 kilometers per hour. And while we'll never mine these alien gemstones, the trip alone would vaporize any probe. They offer something far more valuable: proof that the universe's most dazzling phenomena often hide in the least expected places. Neptune's diamond rain isn't just a planetary quirk. It's a reminder that even the coldest, most distant worlds can harbor storms of breathtaking extravagance. On March 19, 2008, the night sky briefly hosted the most distant object ever seen by the naked eye, and it wasn't a star, a planet, or even a supernova. It was JRB 080319b, a gamma-ray burst so cataclysmic its afterglow outshone the entire Milky Way despite erupting 7.5 billion light-years away. For 30 seconds, this cosmic flashbulb burned with the intensity of a magnitude 5.8 star visible without telescopes from rural areas, before vanishing into oblivion. To put that in perspective, the light that reached Earth that night began its journey when the universe was half its current age, before our solar system even existed. What unleashed such staggering violence? Scientists believe GRB080319b was a long-duration gamma-ray burst, the death scream of a massive star collapsing into a black hole. As the star's core imploded, twin jets of plasma moving at 99.999% the speed of light pierced through the dying star like cosmic blowtorches. These jets, focused into beams narrower than a few degrees, carried enough energy to outshine 1,000,000 trillion suns. The burst's visible brightness was just a side effect. The real devastation came in the form of gamma rays, invisible, high-frequency radiation capable of shredding DNA and ionizing atmospheres across entire galaxies. Now imagine if such an event happened closer, much closer. A gamma ray burst within our own galaxy, even 10,000 light-years away, would deliver a double dose of annihilation. First, the initial blast would bathe Earth's dayside in radiation equivalent to 1,000 kiloton nuclear explosions per square kilometer. The ozone layer would evaporate within hours, exposing all life to lethal ultraviolet radiation from our own sun. Second, the gamma rays would trigger chemical reactions in the atmosphere, producing nitrogen oxides that would cloak the planet in smog for decades, blocking sunlight and plunging temperatures into a deep freeze. Photosynthesis would collapse, followed by the food chain. But here's the real nightmare. Unlike asteroids or supernova, gamma-ray bursts offer no warning. Their jets travel at near light speed, meaning the first sign of danger would be the radiation itself hitting us. By the time we saw the flash, it would already be too late. The only saving grace: these events are exceptionally rare in mature galaxies like the Milky Way. Most occur in distant, metal-poor regions where massive stars still form in volatile environments. Yet GRB080319b remains a haunting reminder. The universe doesn't need proximity to make its presence felt. Even across billions of light years, its most violent children can reach out and touch us, briefly lighting up our sky with a glimpse of oblivion. The sun doesn't just shine, it rages. High above its fiery surface in a layer called the chromosphere, storms unlike anything on Earth twist into existence. These aren't ordinary solar flares or sunspots. They're plasma tornadoes, monstrous vortices stretching 50,000 kilometers into space, tall enough to wrap around Earth 4 times over. Picture a whirlwind of superheated gas, its winds screaming at 500,000 kilometers per hour, temperatures soaring to 5,000 degrees Celsius, and magnetic forces strong enough to rip atoms apart. This is weather rewritten by the laws of astrophysics, where the very concept of a storm gets turned inside out. What fuels these cosmic twisters isn't air pressure or temperature differences, but the sun's chaotic magnetic field. Like invisible hands twisting ropes of plasma, these fields spiral upward, dragging ionized gas with them in a violent dance. The result, a funnel of charged particles so destructive it could strip a planet like Mercury down to its bare core in hours. The tornadoes don't just rotate, they writhe, their bases anchored to the sun's surface while their tops lash outward, flinging material into space like a cosmic slingshot. Some even collapse under their own weight, collapsing back into the chromosphere with enough force to trigger shockwaves visible across the solar system. The sheer energy of these tornadoes defies comparison. A single one releases more power in a minute than humanity has consumed in its entire history. Yet what's truly unsettling is how common they are. At any given moment, thousands rage across the sun's surface, their collective fury shaping the solar wind, the stream of charged particles that bathes our entire solar system. When these tornadoes erupt near sunspots, they can hurl coronal mass ejections toward Earth, threatening satellites, power grids, and even astronauts with radiation. But here's the twist. These plasma tornadoes might hold the key to one of the sun's greatest mysteries: why its outer atmosphere, the corona, is millions of degrees hotter than its surface. Some scientists believe the tornadoes act as energy elevators, transporting heat from the sun's interior to its outer layers. Others think their twisting magnetic fields generate intense currents, heating the plasma through a process called magnetic reconnection. Either way, they're more than just cosmic spectacles. They're engines of solar violence, sculpting the environment of every planet that orbits our star. And while we're safe from their direct wrath here on Earth, these tornadoes serve as a reminder. Even the sun's quiet periods are anything but peaceful. Beneath that golden glow lies a tempest of unimaginable ferocity, where magnetic chaos births storms that make hurricanes look like breezes. For astronomers, they're a laboratory for extreme physics. For the rest of us, a humbling glimpse into the fury that fuels the very light we depend on. Somewhere in the vast cosmic freezer between stars drifts a world of perpetual winter, Ogle 2016 BLG 1195 LB. This isn't just a cold planet, it's a cryogenic wasteland where temperatures plunge to negative 220 degrees Celsius, so frigid that even the air has frozen solid, coating the surface in a layer of atmospheric ice as hard as concrete. Forget snowstorms here, the sky itself has collapsed, leaving behind a desolate plain of nitrogen and oxygen glaciers under a starless void. What makes this ice ball even more alien is its birthplace. Unlike Earth, which orbits a warm yellow sun, Ogle 2016 BLG 1195 LB circles an ultra-cool dwarf star, a dim, cherry-red ember so faint it barely casts a shadow. The feeble starlight that reaches the planet's surface carries less warmth than a candle held a mile away, leaving the landscape locked in a deep freeze that's lasted billions of years. Yet beneath this frozen shell, scientists suspect something astonishing might lurk. A subsurface ocean trapped between layers of ice, kept liquid not by sunlight, but by the crushing pressure of the planet's own weight. Imagine diving into this abyss. The ice above you would stretch downward for dozens of kilometers, its crystal structure warping under such extreme pressure that it forms exotic phases like Ice 6 or Ice 7, molecular arrangements denser than any ice found on Earth. The ocean itself would be a nightmare of physics. With no sunlight to fuel photosynthesis, any potential life would rely on chemosynthesis, drawing energy from hydrothermal vents or chemical reactions in the water. But the pressure here would dwarf even the deepest trenches of Earth's oceans, squeezing water molecules so tightly they behave like a supercritical fluid, neither fully liquid nor gas. And then there's the strangest possibility of all, tidal heating. If Ogle 2016 BLG 1195 LB orbits close enough to its dim star, gravitational forces might flex its icy crust, generating enough internal heat to keep the subsurface ocean churning. That means this frozen hell could, against all odds, harbor the ingredients for life, trapped in perpetual darkness under a ceiling of ice thicker than continents. What's truly humbling is how common worlds like this might be. Ultra-cool dwarf stars outnumber Sun-like stars 10 to 1 in the Milky Way, and many could host similar ice-bound planets. Some might even have geysers erupting through cracks in the ice, spewing plumes of salty water into space, a tantalizing sign for astronomers searching for life beyond Earth. So while Ogle 2016 BLG 1195 LB may seem like a dead world at first glance, it's a reminder that the universe loves to hide its secrets in the most hostile places. Where we see only a frozen wasteland, nature might be brewing something extraordinary, proof that even in the coldest corners of the cosmos, the spark of life finds a way. At the center of the Virgo cluster, a cosmic predator lurks, one that has spent billions of years devouring its neighbors. Messier 87 isn't just any galaxy. It's a celestial cannibal, its appetite so vast it swallowed entire galaxies whole. And the engine behind this destruction, a black hole so colossal, it makes Sagittarius, a star, look like a pebble weighing in at a staggering 100 billion times the mass of our Sun. This isn't just gravity's victory, it's the ultimate demonstration of cosmic dominance. The Event Horizon Telescope's iconic image of M87's black hole, a fiery ring framing an abyss, reveals only part of the story. That glowing halo isn't just hot gas, it's the last scream of matter being shredded into oblivion, twisted into a swirling disk as it spirals toward the event horizon. But the real horror lies in what we can't see, the gravitational aftershocks of past meals. The galaxy's halo is littered with the remnants of devoured dwarf galaxies, their stars stretched into ghostly streams that orbit like cosmic breadcrumbs, marking a trail of destruction spanning 12 million light-years. What makes M87's black hole especially terrifying isn't just its size, it's its efficiency. While most supermassive black holes flicker between feeding frenzies and dormant periods, this one is a perpetual devourer. Jets of plasma blast outward at near light speed, stretching 5,000 light-years into space, a testament to the raw power unleashed as matter falls in. These jets aren't just byproducts, they're weapons, carving cavities in intergalactic gas so vast they could fit dozens of Milky Ways inside. Any galaxy straying too close wouldn't just be torn apart, its gas would be funneled into the black hole's maw, fueling new eruptions that sterilize entire swaths of the cluster. Yet M87 is more than a destroyer, it's a time capsule. The orbits of its surviving globular clusters, ancient balls of stars it hasn't yet consumed, reveal the galaxy's violent history. Some move in bizarre, retrograde paths, suggesting they were stolen from galaxies long since digested. Others hover at the edge of the black hole's influence, a reminder that even the universe's most relentless predators leave survivors for now. And here's the chilling thought, M87 won't stop. As the Virgo cluster continues collapsing under gravity's pull, more galaxies will fall into its grasp. Billions of years from now, it may become a fossil galaxy, the sole remnant of a cluster that once teemed with stellar cities. For astronomers, it's a living laboratory, showing how black holes shape galactic evolution. For the rest of us, a humbling glimpse of what happens when the universe decides there's only room for one. In August 2017, the universe threw a tantrum so violent, it sent ripples through the very fabric of space and time. Two neutron stars, each so dense, a teaspoon of their material would weigh 1 billion tons, spiraled toward each other in a death spiral lasting hundreds of millions of years. When they finally collided 130 million light-years away, the impact unleashed something extraordinary. GW170817, the first neutron-star merger ever detected by humanity. This wasn't just a celestial crash, it was a cosmic alchemy experiment gone wild. A fireworks display of physics that forged enough gold and platinum to outweigh our entire planet. The moment of impact defied imagination. As the star's crust shattered, their cores, a soup of neutrons and exotic particles, splashed outward at nearly the speed of light, forming jets of material so hot they briefly outshone every star in their host galaxy combined. The explosion, called a kilonova, bathed space in a radioactive glow as heavy elements like uranium and plutonium cooked in the cosmic crucible. But the real surprise: the sheer volume of precious metals forged in seconds, an estimated 10 Earth masses of gold alone, flung into the void like glitter from a detonating safe. Yet beauty came with brutality. The kilonova's gamma-ray burst, a narrow beam of lethal radiation punched through space with the energy of 1 billion suns. Had Earth been within its path, even from thousands of light-years away, the effects would have been catastrophic. The initial gamma flash would have ionized our upper atmosphere, triggering nitrogen oxides that choked the skies in a years-long twilight. Ozone depletion would have exposed every living thing to deadly ultraviolet radiation, while the secondary particle shower bombarded the surface like a radioactive hailstorm. What's truly humbling is how much we learned from this one event. the gravitational waves detected by LIGO and Virgo confirmed Einstein's predictions with stunning precision, while telescopes caught the aftermath in every wavelength from X-rays to radio. For the first time, scientists witnessed the origin of heavy elements, proving that the gold in your jewelry was likely born in a cataclysm like this, billions of years before our solar system formed. But GW170817 isn't just a relic, it's a warning. Neutron star mergers happen all across the universe, and while the odds of a lethal gamma ray burst hitting Earth are slim, they're not zero. Some researchers suspect past extinction events might trace back to similar explosions, their radiation signatures buried in ancient rock layers. For now, we can marvel at the data and be grateful we witnessed this collision from a very, very safe distance. Deep in the cosmic archives of theoretical physics lies a nightmare so potent it could rewrite the fate of entire galaxies in an instant: the dark star. Not the familiar black holes or neutron stars of our universe, but something far more exotic. A star forged not from matter, but from its evil twin antimatter. Picture a celestial body identical in size and shine to our sun, yet composed entirely of particles with opposite charge. Where ordinary stars radiate warmth and light, this doppelganger would burn with the same brilliance until it brushed against even a speck of normal matter. Then annihilation, not just a supernova, not just a gamma-ray burst, an explosion so violent it could sterilize a galactic arm in seconds. The mathematics behind dark stars reads like a cosmic horror story. When matter and antimatter meet, they don't just combust, they vanish in a flash of pure energy, converting their entire mass into radiation according to Einstein's infamous E=mc². A single gram of antimatter colliding with matter unleashes the energy of 43 kilotons of TNT, roughly 3 times the force of the Hiroshima bomb. Now scale that to a star. A dark star the size of our sun touching a molecular cloud would detonate with the power of 10,000 supernova. Its gamma-ray blast so intense, it would ionize atmospheres light years away, turning promising planets into radioactive wastelands. What makes this scenario especially chilling is how stealthy such a star could be. To telescopes, it would look identical to any other same spectrum, same luminosity. Only by detecting the absence of certain neutrino emissions or the anomalous gamma-ray halo from occasional interstellar matter drifting into its grasp might astronomers suspect something was amiss. Some theories even suggest dark stars could form naturally in regions where antimatter somehow clumped during the early universe, hidden among ordinary stars like wolves in sheep's clothing. Yet the universe seems mercifully devoid of these potential apocalypse engines. The Big Bang should have created equal parts matter and antimatter, yet we find almost none of the latter today, one of physics' greatest unsolved mysteries. Some process must have favored matter's survival, sparing us from a cosmos riddled with dark stars. Or perhaps they did exist in the ancient universe, their cataclysmic death seeding the void with heavy elements and radiation that helped shape the galaxies we see today. For now, dark stars remain a terrifying what if, a reminder that the universe could have been far more dangerous than it already is. Their hypothetical violence underscores a profound truth. In the grand cosmic ledger, annihilation isn't just possible, it's the default outcome when opposing forces meet. And that's a lesson written not in starlight, but in its absence. Somewhere beyond the stars, hidden behind the Milky Way's own dust and gas, an invisible hand tugs at our galaxy with irresistible force. The Great Attractor isn't just pulling us, it's dragging hundreds of thousands of galaxies through the cosmic void at 22 million kilometers per hour, a silent river of stars flowing toward something we still struggle to comprehend. This gravitational anomaly, 400 million light-years away in the constellation Norma, doesn't glow with visible light or blast radiation across space. Its presence is known only by what it does to everything around it. bending the paths of entire galaxy clusters like a magnet pulling iron filings through water. The scale of this phenomenon beggars belief. At its heart lies the Norma cluster, a dense knot of galaxies, but that alone doesn't explain the gravitational punch this region packs. Current theories suggest the Great Attractor might be the core of the Laniakea supercluster, a filamentary web of 100,000 galaxies spanning 500 million light-years. Imagine a cosmic whirlpool where galaxies spiral toward the center over billions of years, merging in slow-motion collisions that reshape the local universe. Our own Milky Way is caught in this flow, destined one day to join the celestial pileup, though not for tens of billions of years. What makes the Great Attractor especially eerie is the obstacle blocking our view, the so-called zone of avoidance, a thick band of dust and stars from our galaxy's disk that obscures nearly 20% of the extragalactic sky. It's as if the universe hung a curtain across the very phenomenon we're trying to study. X-ray and radio telescopes have pierced this veil to reveal an even more unsettling truth. The Great Attractor itself might be falling toward something larger. The Shapley supercluster, 800 million light-years distant, appears to exert its own pull, suggesting our motion through space is part of a cosmic chain reaction spanning unimaginable distances. The implications rewrite our understanding of the universe's structure. Galaxy clusters were once thought to move randomly, like leaves drifting on a pond. Now we see them as part of immense rivers flowing along filaments of dark matter, the invisible scaffolding shaping everything we observe. The Great Attractor may be just one node in this web, a gravitational way station on a journey whose ultimate destination remains unknown. Yet for all its power, this cosmic behemoth isn't unique. Similar mass concentrations dot the universe, each pulling galaxies into their grasp. What sets the Great Attractor apart is our place in its grip, a front-row seat to watch as the local universe rearranges itself on scales so vast they defy human intuition. As new telescopes probe deeper into the zone of avoidance, each observation peels back another layer of the mystery, revealing not just where we're going, but how the cosmos choreographs its grandest motions. One day, the curtain will lift entirely, and when it does, we may find ourselves staring into the heart of gravity's greatest masterpiece. From the crushing depths of supermassive black holes to the silent genocide of dark matter halos, we've journeyed through 25 cosmic nightmares where the universe flexes its most brutal might. These aren't just distant curiosities, they're reminders of how fragile our existence truly is. A single gamma-ray burst, a wandering hypervelocity star, or a rogue black hole could rewrite Earth's story in an instant. The cosmos doesn't hate us, it simply doesn't care. Yet here we are, on a pale blue dot where air doesn't vaporize us, where gravity doesn't spaghettify our bones, and where the sky rains water instead of diamonds or acid. For all the universe's fury, Earth remains a sanctuary, a statistical miracle nestled in the quiet suburbs of the Milky Way. Those same forces that sculpted quasars and magnetars also carved our oceans, our mountains, and the atoms in our veins. The violence out there makes the calm down here extraordinary, so the next time you look up, remember, the night sky isn't just a spectacle. It's a warning, a classroom, and a mirror reflecting our improbable luck. Every discovery, whether a hellish exoplanet or a wandering void, sharpens our gratitude for this sheltered rock we call home. The universe may be indifferent, but we don't have to be. Stay curious, the next revelation is always waiting. Subscribe now, and let's keep unraveling the cosmos together, one wonder at a time.